The topic is polynomials and polynomial functions. The first objective in this topic: define term, constant, polynomial, monomial, binomial, trinomial, degree of a term, and degree of a polynomial. So, an example of a polynomial would be something like this: multiple terms, variables raised to different powers, numbers in front. And we're going to start by defining these things. So the parts of a polynomial that are separated by pluses and minuses, the pieces that are added together, they are called terms. And here, since this could be 3x squared plus 2x plus -1, this is 1, 2, 3 things added together. This has 3 terms. So you could think of it as added or subtracted, but in terms of the technicality, it's the things added together. And why am I making a difference there? Because each term has a coefficient. The coefficient is the number in front of the x. So here, the coefficient would be 3. Here, the coefficient would be 2. Here, we don't have an x. What does that mean? Well, just like having just a single x is x to the first power, having no x at all is like having x to the 0 power. And now what's the number in front of the x to the 0? It's a -1. This is why I differentiated between, hey, originally it was minus, let's think of it as plus a negative. Because when we look at what's added together, we can see it's plus -1 x to the 0. So the coefficient is what we call the number in front of the x. We can talk about the degree of the polynomial. The degree is the highest power of x. So what was the highest power of x we had here? 2. So the degree here is 2. It's a second degree polynomial. Something that has 3 terms has a special name. It's a special type of polynomial called a trinomial. Because you're all going to try. Now, try like 3, triangle, tricycle, 3. Triple. 1, 2, 3 terms is a trinomial. Anything more than 3 terms, we just call a polynomial. But we also have a special name for 2 terms. If a tricycle has 3 wheels, what do we call the thing with 2 wheels? A bicycle. A binomial, that's 2 terms. Trinomial was 3 terms. And we even have a special name for a 1-term polynomial. A monomial. Back before stereo, there was mono, 1 speaker instead of 2, 1 term, monomial. Normally, polynomials are written in descending powers of the variable, x squared, x, no x. But sometimes they can be written like this. The y squared doesn't necessarily have to be written first. This has 2 terms. It would be called a binomial. What's the degree? The degree would be the highest power of x, or in this case, the highest power of y. Highest power is 2, so the degree is 2. There are different coefficients here. There's many different coefficients. There's positive 10, there's negative 7. Many, 2, many, whatever. When we talk about the leading term, that means, hey, that same term that you picked the degree from, go ahead and think of that, even if it's not in the first position, as the leading term. So if you were asked to find the leading coefficient, pretty sure I spelled that wrong. Nope, I'm good. The leading coefficient would be the coefficient of the leading term. Since the leading term is the term with the highest power, since the minus would be with the coefficient, the leading coefficient here would be negative 7. So those are some of our general terms. Now, sometimes the degree isn't easy to spot. Let's say we had negative 4, x to the 4th, y to the 7th, plus x squared, y to the 5th, plus 5, x, y to the 4th. Here, we don't just have x's, we don't just have y's, we have a mixture of x's and y's. So would this term have a degree of 4? Would it have a degree of 7? Would this have a degree of 2? Would it have a degree of 5? Would this have a degree of 1 or 4? Well, it turns out when we have 2 variables in the same term, we add the coefficients together, just like with our exponent rules. When we multiplied, we added the exponents. We still add the exponents to get the degree. Now, we can't turn this into x, y to the 11th, or x to the 11th, or y to the 11th. This can't be anything but x to the 4th, y to the 7th. But the degree of the term would be 4 plus 7 would be 11. Not the degree of the polynomial, just the degree of the term. To get the degree of the polynomial, we would have to look at the degree of each term. Whatever the highest one is, that would be the degree of the whole polynomial. Then we could determine the leading coefficient, presuming that there aren't two terms with the same coefficient. Here, the degree would be 2 plus 5, or 7. Here, the degree wouldn't be 4. Yeah, we only see a 4. But when we just have an x, that's an x to the first power. So the degree would be 1 plus 4, or 5. So this is actually written in descending degree. The highest degree would be for this term here, which means this is the leading term. -4 is the leading coefficient. And the degree of the whole polynomial, which, by the way, is a 3-term, so it is a trinomial. The degree would be 11. And we couldn't simplify this at all, because remember, to add or subtract, we need like terms. Like terms are the same variables raised to the same power. There are no more x to the 4th, y to the 7ths. There are no more x squared, y to the 5ths. There are no more x, y to the 4ths. So this cannot be combined any more than it already is. Which actually brings me to our next topic. Objective 3 in this topic. Combine like terms review. So like terms are terms that contain exactly the same variables raised to exactly the same powers. Warning, only like terms can be combined through addition and subtraction. If they're not like terms, we can't combine them. In A, our two terms are like terms. They're both y's, and the y's are both raised to the first power. -4 of them plus 2 of them gives us -2 of them, -2y. In B, they're both z's, but they're not like terms because the z in the first term is raised to the first power. The z in the second term is raised to the third power. These terms cannot be combined. C, they're both x cubes. They are like terms. We can combine them. Be careful. I've had students look at this and say, well, clearly the answer is 15 because we have 15x cubed and we're taking away the x cubed, and that leaves us with 15, which is logical, but incorrect. 15x cubed minus x cubed means 15x cubed minus 1x cubed. And 15 of them minus 1 of them is 14 of them. 14x cubed. We're not erasing the entire x cubed. We're just taking 1 away from the 15 of them. And in part D, 7a squared minus 5 minus 3a squared minus 7. We have two sets of like terms. We have two terms that are a squared. We have two terms that are constants. We can pick up and move the terms so that the like terms are next to each other, but we are sure to move the sign in front, the sign to the left, with the term. So that's a negative 3a squared traveling around. That is a negative 5 traveling around. 7a squared minus 3a squared, 7 of them minus 3 of them is 4 of them, 4a squared. Negative 7 minus 5 is negative 12. 4a squared minus 12. Objective 4 in this topic is add polynomials. Let's say we had 3t cubed plus 2t squared minus 5t, and that's a trinomial, 3-term polynomial. And we're going to add to that t cubed minus 6t. We're going to add this trinomial and this binomial. Well, when we're adding, our rule is going to be we don't need the parentheses. So we'll rewrite it without the parentheses. That's our rule for adding. Just drop the parentheses altogether. Only for adding. And then combine like terms and simplify, just like we used to do. Nothing new, nothing different. Do we have any more t cubes? Yes, right here. 3 of them plus 1 of them gives us 4 t cubed. Then plus 2t squared. Are there any more t squareds? No. So plus 2t squared. Minus 5t. Are there any more t's? Yeah, right here. Minus 6t. Negative 5 minus 6 more would be negative 11 t's. And I can't combine anymore. So that's my answer. Let's do another. Only way we can make this more difficult is to throw some fractions in there. Let's take a look at two-thirds w squared minus w plus 1/8, this polynomial, plus 4/3 w squared plus 8w minus 1/4. We're adding 2 trinomials. Since we're adding, our special rule is just drop the parentheses. And then it just becomes adding and subtracting like terms. So let's add our w squareds. 2/3 plus 4/3 is 6/3. 6/3 is just 2. 6/3 is 6 divided by 3. That's 2w squared. Then we have negative w plus 8w. That's like negative 1 plus 8. That's positive 7w's. Taking care of those. Finally, we have plus 1/8 minus 1/4. Got to do the math. Well, this is the same as plus 1/8. 1/4 is 2/8. Positive 1 minus 2. That's negative 1. Negative 1/8. And again, that's because 1/8 minus 2/8 is 1 minus 2/8, which is negative 1/8. And then we can't simplify anymore from here. Let's make this a little more complicated. No, not super fractions. It's not called super fractions, but that kind of is a thing. 2 variables instead of 1. Let's take a look at a squared b plus 7ab plus 6, and we're going to add to that 5a squared b minus 2ab minus 7. Again, we're adding 2 polynomials. Special rule is drop the parentheses. And then we're just going to combine like terms. First, we have our a squared b's. One of them plus 5 of them is 6 of them. 6 of those a squared b's. Then our ab's, we have positive 7 minus 2. That would be positive 5 of the ab's. And then finally, positive 6 minus 7 is negative 1. Not so bad. Dare I say, maybe easy? Maybe? Before we do subtraction, let's go ahead and talk about taking the opposite of a polynomial. Objective 5 in this topic is subtract polynomials. If I had 5a minus 2b minus c, and we wanted to take the opposite, that's like taking the opposite of the entire thing. It's not like, it is taking the opposite of the entire thing. It's imagining parentheses around it, because the parentheses are what keeps it the whole thing. If we are subtracting this, we are subtracting in parentheses the whole thing. Why am I beating this into the ground? I did that earlier, and I think I had a point. The point here is, how do we clear parentheses? We distribute. So taking the opposite of a polynomial is the same as distributing the negative, taking the opposite of each term. So the opposite of positive 5a is negative 5a. The opposite of negative 2b is positive 2b. The opposite of negative c is positive c. So it's not just dropping the parentheses, it's distributing the negative. This is why our special rule only works for addition, because when we are subtracting a polynomial, we can't just drop the parentheses. We have to distribute the negative. So now let's use this information and the resulting kind of rule that we get of how subtracting is different than adding the polynomials. And let's do 3x squared plus 2x minus 5 minus 4x squared minus 7x plus 2. Well, if we were adding, we could just drop the parentheses. But we can't do that here because as we start dropping the parentheses, we run into this minus parentheses. So to continue, we have to distribute the negative. Minus 4x squared plus 7x minus 2. So again, can't just drop the parentheses because the signs of everything inside have to change. Positive becomes negative. Negative becomes positive. Positive becomes negative. But now, parentheses are gone through distribution of the negative, and we just combine like terms. 3x squared minus 4x squared. 3 minus 4 is negative 1. Negative 1x squared is just negative x squared. Positive 2x plus 7x. 2 plus 7 is positive 9 of the x's. Negative 5 minus 2 would give us negative 7. So when we subtract these, negative x squared plus 9x minus 7. If you need a break, take a break. I'm not going anywhere. I'm going to deliver the next one in words. Subtract the polynomial x squared y minus 3 from the polynomial 6x squared y minus 2xy plus 5. Here, the wording tells us the order, and the order is important. It says subtract this from that, which means we start with that, and from that, we subtract this, minus x squared y minus 3. So when it says subtract this from that, that means you have that first and you are subtracting this. You are minusing this. Minusing that from that thing. I'm going to give myself more room now that we've translated it. I'm going to write it up here, but I'm going to do it without parentheses. So we're okay to always drop it from the first one, but then when we get to the minus, that means we have to distribute it. So minus x squared y plus 3. And to finish this off, look for like terms. Let's start with x squared y's. There's an x squared y right there. That one, no. That's just xy, not x squared y. Positive 6 minus one of them would be positive 5x squared y. And then we only have this minus 2xy plus 5 plus 3 is plus 8. I'd like you to try one. I'll give a little bit of time in the video, but seven p squared q minus 6 minus 2p squared q plus 4pq plus 4. Go ahead and do this one. You don't even have to pause. I'm thirsty. Should be finishing up now. Okay. Dropping the parentheses means distributing the negative here. Minus 4pq minus 4. Combining like terms. 7 of them minus 2 of them is 5p squared q's. You can go minus 4pq next. or oops, or you can do the -6 minus 4 is -10 next. Whatever order on those last two. But either way, it needs to be a -4 PQ and a -10.
This time we're subtracting. 9a squared b squared plus 7ab minus 4ab squared. That's our first polynomial. We're subtracting from that. 6b squared a plus 3ab minus 4 minus 10b squared. We want to get rid of all the parentheses first. We can drop them from the first one no matter what. We're subtracting. So to get rid of the second set, we distribute the negative. Minus 6b squared a minus 3ab plus 4 plus 10b squared. Now here we have ab squared. Here we have b squared a. Those are actually like terms. And you might be saying, but they look different. How are they like terms? Well, remember, to be a like term, you have to have the same variables. We have the same variables, a and b. And they have to be raised to the same powers. Well, the a is to the first and the b is squared. They are the same. They're just in a different order. So when we go to combine, we just have the 9a squared b squared. And then we have 7ab minus 3ab. That's going to be positive 4ab. Negative 4ab squared minus 6b squared a, or minus 6ab squared. Negative 4 of them minus 6 of them is negative 10 of them. And then we have our plus 4. Then we have our plus 10b squared. So the key to simplifying this one was recognizing that ab squared is the same as b squared a. The topic is multiplying polynomials. The first objective in this topic is multiply two polynomials.
2x cubed times 3x squared. What? We did this already? Wow. Yeah, we did this already. We did this with our exponent rules. 2 times 3 is 6, sure. But what's x cubed times x squared? We add the exponents. So 6x to the 5th. But we did that. We know how to do that. Multiply the numbers. Multiply the x's. To multiply the x's, we add the exponents. We've been prepping for this without realizing it. So let's do another. Three x squared y to the 7th times 5 x cubed y. Well, this is just an extension of what we just did. Multiply the numbers, then multiply the x's. Here we'll multiply the numbers, then we'll multiply the x's, then we'll multiply the y's. Easy peasy, lemon squeezy. 3 times 5 is 15. X squared times x cubed is x to the 2 plus 3. Y to the 7th times y is y to the 7 plus 1. So 15 x to the 5th, y to the 8th. Not bad. You want to try one? How about -8 r cubed s times -4 r to the 4th s to the 4th. Now, if we were going to add these, we wouldn't be able to. They're not like terms. Multiplication, we don't have to worry about anything like that. -8 times -4 is positive 32. R cubed times r to the 4th is r to the 3 plus 4. S to the 1st times s to the 4th is s to the 1 plus 4. 32 r to the 7th, s to the 5th. That's it. Okay, let me make it more complicated. So far, adding, that's a bunch of stuff we knew how to do already. Subtracting, that's a bunch of stuff we knew how to do already. Multiplication, so far looking like a bunch of stuff we know how to do already. Or at least something we'd be able to figure out. Hopefully that trend continues. When we multiply the monomial 5y cubed times the trinomial 2y squared minus 7y plus 6. Well, now we got to do a little more thinking. Well, something on the outside of parentheses times a bunch of stuff, the distributive property. We know how to do monomial times any number of terms we distribute. So 5y cubed times 2y squared would be 10y to what power? Not 6th, 5th. 3 plus 2 is 5. That's the first term. Positive times positive is positive. What's the second term going to be? And by the way, since there are 1, 2, 3 terms in this distribution, our answer is going to have 1, 2, 3 terms. Positive 5 times negative 7 is negative 35. Y cubed times y is y to what power? 3 plus 1 is the 4th power. And then positive 5y cubed times 6, positive 30y cubed. And that's that. Another one? Why not? Fractions, okay. Let's take a look at 8 st cubed times 1/2 s squared minus 1/4 st. Same thing. We take the monomial on the outside, we multiply it times both terms on the inside. Since there's 2 terms here, our answer will be 2 terms. I'm going to make my arrows a little bit more shallow, just so I have more room to write a step under here. 8 times 1/2 is 4, because that's 8 over 1 times 1 over 2, which is 8 over 2, which is 4. So 8 times 1/2, positive 8 times positive 1/2 is positive 4. S times s squared would be s to the first times s squared, s to the 1 plus 2, s cubed. T cubed times, whoa, there's no t's. Oh, what do we do? Oh, no. Well, there's no t's. 3 plus 0 is 3. So just the t cubed. That's just the first term. And now 8 times negative 1/4. Positive times negative is negative. 8 times 1/4 is 8 over 4 is 2. It's an s to the first, t to the first here. S times s is s squared. T cubed times t, 3 plus 1 is 4. And that's it. 4s cubed t cubed minus 2s squared t to the 4th. Now,
Objective 2 in this topic is multiply binomials.
I want to show something like this. A binomial times another binomial. So let's take a look at x plus 2 times x plus 3. Now, if we were to kind of use the logic of what we just did, we could take this x plus 2 and consider it the thing on the outside. And we can multiply it by each of these things. That means we would have x plus 2 times x. And then we would have x plus 2 times positive 3. So positive 3 times x plus 2. So that's one distribution. But then we would have another level of distribution multiplying just the x times both terms. And then again, multiplying the positive 3 times both terms. And we would end up with x squared plus 2x, and then over here plus 3x, over here plus 6, positive 3 times positive 2. And then we could combine these center terms, 2x plus 3x is 5x. And we would get that this is x squared plus 5x plus 6. Multiplying two binomials together, and we end up with a trinomial as an answer, not another binomial. This is the idea of double distribution. When it's just a binomial times a binomial like this, there's a bit of a shortcut where we would multiply the x times both things, and then we would multiply the 2 times both things, because that's what we ended up doing anyway in the long run. And here, multiplying this x times this x, it's like multiplying the first terms together. And then this x times that 3, it's like multiplying the outside terms together, or the outer terms. And then we would multiply the 2 times the x. These are the inner terms. And then the 2 times the 3, these are the last terms. First, outer, inner, last. FOIL. First, outer, inner, last. FOIL. So when you talk about foiling, it can only be done when there's two binomials, and you could do the first, the outer, the inner, and the last. But notice you don't have to remember what FOIL means. You can just do double distribution. That's all it's saying to do. It's saying, hey, take this first thing and multiply it by everything, and then take this second thing and multiply it by everything. The first terms, x times x, is x squared. The outer terms, x times 3 is plus 3x. Inner terms, 2 times x plus 2x. Last terms, 2 times 3 plus 6. X squared plus 5x plus 6. We have something called the FOIL method. FOIL stands for first, outer, inner, last. First meaning the product of the first terms, outer meaning the product of the outer terms,
I meaning the product of the inner terms, L meaning the product of the last terms. So first is the first terms, outer is the outer terms, inner is the inner terms, last are the last terms. We get those four products, and then we add them together. So the example problem here is 3x plus 1 times 2x plus 5. First, we would multiply the first terms. 3x times 2x gives us 6x squared. Then we would multiply the outer terms. 3x times positive 5 is positive 15x. Then we would multiply the inner terms. Positive 1 times positive 2x is positive 2x. Then we would multiply the last terms. Positive 1 times positive 5 is positive 5. Then we would add it all together. Combining like terms usually means combining the outer and inner. 15x plus 2x is 17x. So 6x squared plus 17x plus 5 is what we would get when we multiply. Notice when we multiply two binomials, we get a trinomial, not another binomial. We might get another binomial in a special case, but usually we get a three-term thing when we multiply two two-term things. So let's multiply y minus 12 times y plus 4 using the FOIL method. So we'll take our problem and we'll look for the product of the first terms. Y times y, that's y squared. And then the outer terms, y times positive 4 is 4y. Then the inner terms, negative 12 times positive y, that's negative 12y. And then the last terms, negative 12 times positive 4 is negative 48. The FOIL method has us add together those four terms. Combine like terms, positive 4y minus 12y gives us negative 8y. So y squared minus 8y minus 48 is the answer. Next, let's multiply 2x minus 4 times 7x plus 5. First, 2x times 7x. Outer, 2x times 5. Inner, negative 4 times 7x. Last, negative 4 times 5. 2x times 7x is 14x squared. 2x times 5 is positive 10x. Negative 4 times positive 7x is negative 28x. And then negative 4 times positive 5 is negative 20. Combine like terms in the center. Positive 10 minus 28 of them. 10x minus 28x is negative 18x. For a final answer of 14x squared minus 18x minus 20. So we multiplied these same two binomials together in the previous section using a different technique, but we arrived at the same product. Is that true? Who knows? If we did get the same product. If we never did it, then this slide was a lie. Let's take a look at this one. Multiply 2y squared plus 3 times y minus 4. We're going to FOIL. First, 2y squared times y is 2y cubed. Outer 2y squared times negative 4 is negative 8y squared. Inner positive 3 times y is positive 3y. And last, positive 3 times negative 4 is negative 12. We have no like terms to combine, so this is our final answer. Another one. 3x minus 7y times 7x plus 2y. Let's FOIL. If we FOIL, we do first 21x squared, outer 6xy, inner negative 49xy, last negative 14y squared. Combine our xy's, and we get a final answer. It's the same that we would get if we did it the old-fashioned way. Take the 3x times the entire 7x plus 2y. Take the minus 7y times the entire 7x plus 2y. First, outer, inner, last. We get the same 4 terms. All we have to do to get to the final answer is positive 6xy minus 49xy. If you did it and got 49yx, just remember yx and xy are the same thing. Positive 6 minus 49 gives us negative 43xy. So our final answer is 21x squared minus 43xy plus 14y squared. Objective 3 in this topic is square binomials. A binomial squared is equal to the square of the first term plus or minus twice the product of both terms plus the square of the second term. So when we see a plus b squared, that's not a squared plus b squared. There is a third term in the center. That third term is twice the first times the second. If it was a plus in the squared binomial, then it's a plus 2 times the first times the second. If there's a minus in the squared binomial, then it's minus 2 times the first times the second. It is helpful later on to be using this formula, but if you struggle with formulas, you are allowed to FOIL with itself. A plus b squared means a plus b times a plus b. FOIL, you'll get the same answer. A minus b squared means a minus b times a minus b. FOIL, you'll get the same answer. X plus 6 squared means x plus 6 times x plus 6. FOIL, you will get the same answer. X times x is x squared. X times 6 is 6x. 6 times x is 6x. 6 times 6 is 36. The inner and outer are the same. So 6x plus 6x gives us 12x. Twice the first times the second. Same as the formula. So that's all the formula is doing. It's foiling it with itself. So if you want to FOIL with itself, go for it. If it gets you the right answer, good job. I'm going to use the formula here, though. You can FOIL 12a minus 3 with 12a minus 3 and get to the answer. But I'm going to square the first. Then I'm going to subtract 2 times the first times the second. Then I'm going to add what I get when I square the second. 12a, the quantity squared, is 144a squared. 2 times 12 is 24, times 3 is 72, so minus 72a. And then 3 squared is 9, so plus 9. The formula gets us there a little quicker. X plus y squared. Square the first, x squared, plus 2 times the first times the second, 2xy, plus square the second, y squared. Two x plus 5y squared. Square the first, plus 2 times the first times the second, plus square the second. 2x squared is 4x squared. 2 times 2x is 4x. 4x times 5y is 20xy. And then when we square 5y, we get 25y squared. B, 6a squared minus 2b. This is still a binomial squared, even though one of the things inside is already squared. Follow the same formula. Square the first, minus 2 times the first times the second, plus the second squared. When we square 6a squared, we get 36a to the fourth. Negative 2 times 6a squared is negative 12a squared, times 2b is negative 24a squared b. And then plus, when we square negative 2b, we get 4b squared. Objective 4 in this topic is multiply the sum and difference of two terms. So another special formula, when we have a plus b times a minus b, in other words, two binomials, but one has a plus in it, the other has a minus in it, otherwise they're exactly the same, that's going to give us a squared minus b squared. And the reason it gives us a squared minus b squared is when we FOIL, the inner and outer products don't double this time. This time they cancel each other out. So 2x plus 4 times 2x minus 4. First would be 2x times 2x, that's 4x squared. Outer would be 2x times negative 4, that's negative 8x. Inner would be 4 times 2x, that's positive 8x. And then last would be plus 4 times minus 4, negative 16. The minus 8x and the plus 8x cancel each other out. We're left with 4x squared minus 16. In other words, square the 2x minus square the 4. So this formula is lovely. 5a plus 3 times 5a minus 3. Square the first, subtract, square the second. When we square 5a, we get 25a squared. When we square 3, we get 9. So 25a squared minus 9 is our answer. This special case is the only time where we can multiply a binomial times a binomial and get a binomial back. Get a binomial back. 8c plus 2d times 8c minus 2d. Square the 8c, subtract, square the 2d. When we square 8c, we get 64c squared, minus, when we square 2d, we get 4d squared. So 64c squared minus 4d squared. Seems simple enough. Uh-oh. Now we're multiplying 3 plus the quantity 2a plus b squared. That means we're foiling 3 plus 2a plus b with itself. I guess that's possible. 3 is the first thing, and then 2a plus b is the second thing. We could use our special formula for squaring two things. Square the first, 3 squared. Take 2 times the first times the second, 2 times 3 times 2a plus b. And then square the second, square the 2a plus b. Doing a little bit of simplification, 3 squared is 9, 2 times 3 is 6. Now we have to square the 2a plus b. Let's use the formula a second time. Bring down the 9, distribute the 6. 6 times 2a is 12a, 6 times b is plus 6b. And then to square the 2a plus b, we square the 2a plus 2 times the first times the second. 2 times 2a times b plus square the second plus b squared. Simplify here. Bring down our 9 plus 12a plus 6b. Squaring 2a gives us 4a squared. 2 times 2 is 4 times a times b, that's 4ab. Squaring b gives us b squared. Are there any like terms that can be combined? We have a constant, we have an a, we have a b, we have an a squared, we have an ab, and we have a b squared. No like terms. So that is our answer. That's an example of why the formula is helpful, because it definitely cuts some time off what we would be doing if we had to multiply that out by hand. Could we even do it without the formula? At this point, who knows? The fifth objective in this topic is multiply 3 or more polynomials. So if we have x minus 3 times x plus 3 times x squared minus 9, we have to multiply 2 of them together, get an answer, and then multiply that answer by the third. Just like if we were multiplying 3 numbers together, we would multiply 2 together and multiply by the third. Same with polynomials. I see 2 of these polynomials that are very nice to be multiplied together. For instance, the x minus 3 times the x plus 3. We can do that first using our multiplication formula. That turns into a difference of squares. Square the first, subtract, square the second. X squared minus 3 squared, or x squared minus 9. Now we have x squared minus 9 times itself, otherwise known as x squared minus 9 squared. So you could FOIL to get the answer, or you could use the special formula where we square the first and then subtract 2 times the first times the second and square the second. And while you're still foiling, I'm at the answer. X squared squared is x to the 4th. Minus 2 times x squared times 9 is minus 18x squared. Plus 9 squared is 81.